Now for the continuation of the solid waste engineering, let us discuss the recycling. Recycling can also be described as closed loop or open loop. When we say of closed loop or the primary recycling, it is the use of recycled products to make the same or similar products. Examples of primary recycling include the use of glass bottles to make other types of glass bottles or aluminum cans to make new aluminum cans. Secondary recycling is the use of recycled materials to make new products with different characteristics than the originals. For example, milk jugs made of high-density polyethylene or the HDPE can be recycled into toys or drainage pipes. Now let's move on to the tertiary recycling. Tertiary recycling is the recovery of chemicals or energy from post-consumer waste materials. Many electronic companies, for instance, recover the solvents used in their manufacturing processes and distill them for reuse. At the lowest and most appropriate technological level, recycled materials are separated at the source by the consumer. Source separation. This is the most appropriate level because it requires the minimum expenditure of energy. Another material that can be recycled is the paper. The paper can be reconverted to pulp that can be pressed into new paper. Because this process results in the breakdown of some of the paper fibers and a reduction in strength of the paper, new pulp material must be added to the recycled paper. So although this has been successful in the recycling of soft drink containers, recycled paper. Now let's discuss the recycling of materials. Several types of materials are commonly recycled, including glass, metals, paper, and plastics. Paper is easily recycled. Recycling papers involves the removal of inks, glue, and coatings. Of the various forms of plastics that are produced and can be recycled, high-density polyethylene is the most common, so known by the Society of Plastics Industry Code number 2, HDPE. This type is used to produce milk bottles, detergent bottles, and film products such as produce bags. So the recycled HDPE is also used to produce protective wrap, grocery bags, and molded products such as toys and pills. Now the polyethylene terephthalate, or the number 1 PETE, is most commonly used originally in the production of carbonated soft drink bottles. Some states have ensured the recycling of a large percentage of this material through bottle bills requiring deposits on soft drink bottles. Although this has been successful in the recycling of soft drink containers, as the consumption of the bottled water has increased, so has the disposal of the water bottles as the municipal solid waste because they are not always covered by bottle bill regulations. So glass is one of the easiest materials to recycle. Almost all of the glass that is recycled is made into new glass containers and bottles. So a small amount is used to make other products such as glass wool, fiberglass insulation, paving material, and building products. In the United States in 2010, only 27.1% of the glass produced was recycled. It is clear that while significant strides have been made in the recycling of bottles containing liquids such as beer, soft drinks, and wine, much work still needs to be done to ensure that the food and other jars and bottles are recycled. So bottle loss can have a significant impact on glass recycling. Now let's move on to the composting. Composting is the controlled decomposition of organic materials such as leaves, grass, and food scraps by microorganisms. The result of this decomposition process is compost, a crumbly, earthy-smelling, soil-like material. The material to be composted contains both carbon and nitrogen sources. Leaves, straw, and woody materials serve as a major carbon source, while the grass and food scraps provide significant nitrogen. A ratio of 30 parts carbon to 1 part nitrogen is necessary to achieve optimal microorganisms growth and energy production. Other problems can occur if the carbon to nitrogen ratio is not 30:1. So because the municipal solid waste in the United States contains up to about 25% yard trimmings and food scraps, composting of this material can greatly reduce the amount of waste that ends up in landfills or incinerators. So the decomposition of the organic materials in composting involves both the physical and chemical processes. During decomposition, organic materials are broken down through the metabolic activities of various invertebrates present in composting material, including the mites, the millipedes, beetles, sawbugs, earwigs, earthworms, slugs, and the snails. So these microorganisms need adequate moisture and oxygen to degrade the organic materials in the most efficient manner. Waste reduction and modification. Source reduction can be accomplished by reducing the quantity of materials generated before they are ever ready for recycling or reuse. This includes the redesign of products or packages to reduce the quantity of material used. Non-toxic materials can be substituted for toxic ones. For example, soy-based or water-based inks can be used. Lead foil on wine bottles can be replaced with aluminum, which can be easily recycled. Freon can be replaced with non-ozone consuming chemicals, and the transformers have also been redesigned and retrofitted to allow for the use of lubricants and insulators other than PCBs. So for example, in 1977, the mass of a 2-liter soft drink bottle was originally 68 grams. Today, the same size bottle has a mass of only 51 grams. So although the amount of plastic in each bottle may seem inconsequential, this reduction has kept 115 million kilograms of plastic per year out of the waste stream. The companies can also use packaging that reduces the amount of damage or spoilage, thereby reducing the mass of material that must be discarded. Now let's move on to the reuse. Other ways of source reduction are the reuse of durable goods, the appliances, furnitures, computers, and etc., by repairing them when they are broken or refurbishing them when they are outdated, donating them to the charity and community groups, or selling them to others that have a direct use for them. Ideally, products should be used more than once, either for the same purpose or for a different one. Reusing when possible is preferable to recycling because the item does not need to be reprocessed before it can be used again. Now let's move on to the solid waste reduction, the combustion process. Combustion is a chemical reaction in which the elements in the fuel are oxidized in the presence of oxygen. The major oxidizable elements in the fuel, in this case, the solid waste, are carbon and the hydrogen. To a lesser extent, sulfur and nitrogen are also present. With complete oxidation, carbon is oxidized to carbon dioxide, hydrogen to water, and sulfur to sulfur dioxide. Some fraction of the nitrogen may be oxidized to nitrogen oxides. The combustion reaction are a function of oxygen, time, temperature, and the turbulence. So as the solid waste enters the combustion chamber and its temperature increases, volatile materials are driven off as gases. Rising temperatures cause the organic components to thermally crack and form gases. So when the volatile compounds are driven off, fixed carbon remains. So when the temperature reaches 700 degrees Celsius, the carbon is ignited. Now, to achieve destruction of all combustible materials, say burnout, it is necessary to achieve 700 degrees Celsius throughout the bed of waste and ash. Now, to achieve the combustion process, we have the different types of incinerators. So first, let us discuss the conventional or the mass-fired incineration. Mass-fired incinerators are the most common form of municipal solid waste incineration. These systems can accept refuse that has received little pre-treatment other than the removal of oversized items such as kitchen stoves and mattresses. Local programs for the removal of potentially hazardous chemicals such as Pesticides and other hazardous household chemicals are necessary to prevent environmental damage. So because the refuse is generally not pre-treated, although it may have some heat value, it is normally quite wet and is not autogenous, meaning self-sustaining in combustion until it is dried. So this conventional type of incinerator uses auxiliary fuel which provides for the initial drying stages. So because of the large amount of the particulate matter generated in the combustion process, some form of air pollution control device is required. Normally, electrostatic precipitators are chosen. So bulk volume reduction in incinerators is about 90%, thus about 10% of the material still must be carried to a landfill. This is an example of a conventional incinerator. And another type of incinerator is the refuse-derived fuel facilities. So RDF, or the refuse-derived fuel, is the combustible portion of the solid waste that has been separated from the non-combustible portion through processes such as shredding, screening, and air classifying. By processing municipal solid waste, refuse-derived fuel containing 12 to 16 megajoules per kilogram can be produced from 55 to 85% of the refuse received. This system is also called a supplemental fuel system because the combustible fraction is typically marketed as a fuel to outside users as a supplement to coal or other solid fuels in their existing boilers. So this is a typical refuse-derived fuel facilities. In a typical system, the municipal solid waste is fed into a trommel or the rotating screen to remove the glass and dirt, and the remaining fraction is conveyed to a shredder for size reduction. Now, the shredded waste may then pass through an air classifier to separate the light fraction, the plastics, paper, wood, textiles, food waste, and smaller amounts of light metals, from the heavy fraction metals like the aluminum and small amounts of glass and the ceramics. The light fraction, after being routed through a magnetic system to remove ferrous metals, is ready for fuel use. The heavy fraction is conveyed to another magnetic removal system for recovery of ferrous metals. Now, the aluminum may also be recovered. The remaining glass, ceramics, and other non-magnetic materials from the heavy fraction are then sent to the landfill. Other thermal treatment process. In addition to incineration, municipal solid waste can be processed by pyrolysis or gasification process. Pyrolysis is the thermal processing of a material in the absence of oxygen. Gasification is the partial combustion in which a fuel is burned with less than a stoichiometric amount of oxygen. It is an energy-efficient technique for the reduction in waste volume and for recovering energy. Both processes convert the solid waste into gaseous, liquid, and solid fuels. The main difference in the two systems is that pyrolysis uses an external heat source to drive the endothermic reactions, whereby gasification reactions are self-sustaining. So that's all for this part, and for the succeeding topics we will discuss on the next lecture video.